All right. Any thoughts, concerns? How's everybody doing? Have people managed to run that file? Run the machine learning stuff?
I'm still a little bit confused about how we are going to submit things, and
All right. Well, that's a reasonable fear. It's the reason might be a little unclear is because we're all making it up as we go here. But I've been busy coding things, and I'm excited to show you what I came up with. My eyes are starting to go.
so sir, just to clarify, we submit labs with tests, so we do both of them. Labs are not tests, right?
No, it's all the same. There's two more things that you need to do,
Okay.
and we'll give you not 24 hours to do them, but as long as the time is left. So it's less of a test and more of an assignment, but it's the same. It's two things to be done.
Okay.
Right.
Sure.
So, and if people are in a panic, let's see if we can resolve. How did you people feel about the last class on Monday? Did that feel like you're okay with that?
Yeah, that was good. But if you can emphasize more, like how Adnan said, how are we supposed to submit? And you said you were going to show us something else today too, right? Related to the lab. Yeah.
Yeah. Let's see if I can find what we're doing here. Python.
And if I understand correct, last class you said the lab 1 was due on the 25th and lab 2 was due December 2nd.
No.
Oh.
Well, there's two issues. When are things due and what do you need to do?
Okay.
You don't have to do labs 1 and 2 because I did them already for you. We'll find other things for you to do. And let's talk today about what I have in mind for you to do. All right? So, these aren't my new slides. Let's make one more attempt to get my new slides down. And then we'll go over to something else. Yeah, here we go. So as I was working along, I thought of a few other things to add here. So let's go over those. And then we will go over my new code and we will talk about what one can do with my new code and see if everybody's as enthusiastic as I am. All right? So holler if you don't get things. The first thing is, remember I had a typo that in brackets it's called the tuple. And one thing that we asked Chester when he was here, we said, what's 2 comma? And 2 comma is like a 2 it's like a tuple, while 2 just by itself is an integer. So that's why you put the comma after it. And I've started using tuples in my code and they're kind of fun. All right, so I just made these slides like seconds ago. I'm kind of excited about how we can learn use neural nets to approximate some function with one variable here. All right, so here is a neural net that has one input and one real output, and it has a bunch of nodes in between, which are just pure thresholds. And just my own imagination, I lay here trying to sleep and I think, what can they compute? And this is what I came up with just thinking. All right, so suppose I put a weight of 1 on this edge and a weight of negative W1 on this weight. This weight here is the one that we shift the threshold from. So you can think about it as having a solid 1 feeding in. So what does this compute, right? It comes out, remember you do a sum on the edges coming into it of to get a Z value. So it's going to be the X times the 1 plus the 1 times the negative. Oh, that's supposed to be a W1, not a W2, but you can, I switched at one point. These slides really were just made, right? So assume those are W1s, right? So everybody get that? And then you rearrange this and you get that. And then we put a little threshold here. So the threshold fires, right? When do you fire? When this thing is greater than, when Z is greater than 0, then Y fires, right? And so you rearrange it. This node fires when X is greater than X1, right? Everybody buy that? And so let's sit here, X is greater than X1. We can draw a line here, X greater than X1. That's over here. On this side, that neuron fires, right? So one thing that's kind of interesting is if I multiply, I put a weight of 1 here. Why did I do that? Well, to make this math easy. But if I scale this by D and scale that by the same D, then that scales this number by D. And we can think about it scaling the 0 by D, and absolutely nothing changes. All right. So that's why we got, might as well be 1s there. And then we bring that into a new neuron, and it has its own constant weight. And what does that give us? That gives us, if we're over here, right? If X is less than, then again, it shouldn't be, that should be a W1. Change all your 2s to 1s, right? If X is less than the W, right? Then what do we get, right? We get this one times the C0 plus this guy's not firing, so it doesn't do anything, right? And so what you get is just C0. That's the value, right? So here we can say, what value do you get in here? When anything less than W1, you get C0, right? And now suppose we're over here, X is bigger than W2. Well, then this one's firing as well, right? This one's, it hits the threshold. So it's sending a 1 along here because these are just straight 0, 1 thresholds. And when the 1 hits the W, it gets a W here. And so this is the value of that it's outputting. Is everybody with me here? Are you good, Shanaz? All right, right. So that gives us, for values bigger on this side, it gives us that value, right? Which is kind of a silly value. I would rather it be C1, right? Because it's a nice, C1 is a better number, right? So what we're going to do is set these to be equal. Instead of C0 plus W, we want C1. So, and then we rearrange it, and it tells us what our W needs to be. So this W down here is going to be replaced with C1 minus C0. And that replaces that, which gives us C1. Right? Does that make sense? Right? And I didn't bring any animations here, but it's good enough. Here we filled the whole thing out, right? I filled out all the layers. And you can see that this is some approximation of our purple function. And just as a test, let's take this green line and compute what the function is there, right? At this point, right, X is less than W is greater than W3 and less than W4, right? So which of these neurons fire? Well, it's the same argument we had before, assuming these weights, right, are sorted, then, right, this number here is bigger than W1, W2, and W3, so those three fire, but it's smaller than W4, so W4, the fourth one doesn't fire. So if now we compute the sum, right, we get ones on the ones that fire and 0 on the one that doesn't fire. And these all cancel, and you get C3 like I was claiming, right? Does that make sense? Anyway, so, oops. When I'm thinking about this, my theory is suppose we had a big neural net with lots of layers and lots of nodes, but for the moment, let's assume that we only had thresholds. And suppose you fix the value of all the input variables except for one, and you graph the output, and you varied the one, right? You varied one of the inputs, and you graph the output. I claim that you would still have a function that's constant like this with D pieces, where D is the number of nodes at the first layer. That's my theory. And one thing you can do is you can run it and see if my theory is true, right? Now, one might also say, well, if you put in a sigmoid, that will round out some of these corners, but it'll still be basically the same. And I don't really know what this would do. So your homework is to try various things, all right? Oh, we saw that already. And we saw this already. These are all slides that didn't quite get deleted. All right. Oh, this is just call by value, call by function. Let's not worry about it. I decided that when I was doing figures, I wanted two figures on top of each other. So I've added a few lines here so that you can get two figures instead of one. And another thing, I like to have an origin so that I can know how these are relative to each other, right? You know, when they have the scale not start at 0, I get a little bit more confused. So here I plotted 0, 0, so it includes the 0. All right. Those are my new slides. So now let's go. You come here, you go here, you go, oh, that's your guys' faces. Let's not bug those. You come down here. Oh, no, that's not where we want to go. Sorry. We could get there that way too. Anyway, the way I go is, where did I give you that link? Oh, I know where it is. I gave you the link here. Sorry. And then we go, these are my the code that I've been changing all through the day and late at night. So let's see what it does. All right. All right, so I made some code here, and I think you only need, some light level of understanding of what it's doing, but you can look at it and see if you want to modify it. And what it does is it tries to print lots of pretty graphs. All right. So what you're able to do is you're able to specify some function that you want to learn. So you go in and you specify a function, and then you can learn, and then you can graph what is the function that it learns. You graph the function that you created, and you graph the function that it learned, and you eyeball them and see how they're different, right? So that's one task you can do. And the other task you can do is that there are many, many, many parameters in this machine learning process, right? So what you can do is you can fix all the parameters except for one of them, and you vary the other parameter, and you plot how well does it learn as you vary that parameter. All right. So that's what your homework is for next Friday, right? And if you think that sounds scary, my hope, though I'm making it up as I go here, my hope is that if anything, it will be too easy for you. All right. But one thing I have to tell you is my code actually isn't completely working right now. I think my side of it is doing what it's supposed to do. And I assume Google's side is doing what it's supposed to do, but somehow there's not a matchup. And so when it gives me a function back, it's really, really, really bad. So there's something in the machine learning that I'm doing wrong. And maybe somehow we'll have to figure out what it is. Chester might be able to fix it. We'll find somebody to fix it. All right. Any quick thoughts, or should I go through this program, how to do it?
I guess it would be better if you go, sir, because
All right.
so we plot. So the first function that we plot the graph, that's kind of
Let's go
given,
through
right?
this. Let's go through this, and I'll
Okay.
show you what I'm doing. All right. And you might panic. You might panic. How do I possibly do what Jeff is asking? Right. And I give you sympathy because I spent the all day yesterday and some of this morning doing it. And it wasn't that hard, but I have more experience doing this stuff than you do, right? So I'm going to show you how I do it, and then all you have to do is do it the same, right? So the first, oops, what's that? That was the first step is, right, it has all these little cells, and what the first cell does is I call them attempt parameters, right? Because you're going to keep attempting to do machine learning, and as you attempt it, you're going to vary some parameter. And I just wrote down a bunch of parameters, and you might find others. And if you want to have others, you just stick them in here. All right. And so here, this is, right, our input is going to be x1 through xn, right? How many pixels you have in the, and that is the number of dimensions. Then each x value is between 0 and some maximum value, right? How many training data do you have? How much test data do you have? Is your function that we're trying to approximate, is it a polynomial or is it an exponential? You may list a whole bunch of different functions here, right? And here, if I'm doing a polynomial, what degree is the polynomial, right? Is it an right? And then I might add some noise to my data so that
Change the top part. Sorry.
What?
Yeah, the degree thing, you dragged it by mistake.
Oh, sorry.
Yeah.
All right. We don't want. Thank you.
No
Because we don't
bugs.
want to
Yeah,
get this saved and mess everybody up. You can't save it. You can't change it, but I can. So we don't want to do that. All right. So we could add noise to our x and y values. How many layers are in your neural net? How many hidden values are at each layer? How many, which activation do you want to put in, right? This is the one that's straight and across, but you might try sigmoids, try different ones. How many epochs? Epoch is how many times you go through all of the data, right? And batch says you do only some of the data at a time, right? You look at 128 of the data, training data, and you decide how to step. And then you look at the next batch and the next batch. All right, so those are all these parameters, right? And what this routine does is it sets them, all right? So how you call it, let me show you how you call it. And this morning, before I had a couple of, right, let me show you. And this morning I changed it, and it cost me an extra hour or two of coding because I had to learn how to do something fancy. But here you call set AP, which is set, what's AP stand for again? The attempt parameters, right? You need to set the attempt parameters, and what it's going to do is these are the defaults, right? So it's going to set everything back to the defaults, and then you get to change things, right? Oh, let me tell you first what this thing is, right? See, it has a curly bracket, and if you look back on my list, that's a dictionary, right? So the key for is numDiments, and it brings back 2, right? So if you see how I use it down here, right? Here I say print AP in dimensions, right? And it gives me 2, right? I say print AP function, and it gives me exponential, right? Well, you might say, hey, wasn't it polynomial up there? And that's because we changed it here, right? So how do you, and here's an if. I say, right, if AP function equals is a returns a Boolean, right? If the function is exponential, then print excellent, right? And it is exponential, so it prints excellent, right? What else do we have here? So the set thing, if you just call, oh, by the way, one of the things that was causing me, why did it take me, longer than I hope? It always takes longer than you hope. And it was because I had forgot kind of about global variables versus local variables. And sometimes I was using AP locally in a routine, and sometimes I was using it globally, and that just caused problems all around, right? So here, right at the top, we make AP a global variable, all right? And so then what does set AP do? It sets them to the defaults, but if you add in here, see, it's just a list. You can add in here as many things as you want. And so here I'm adding that I want to change function to exponential, and I want to change degree to 3, right? Before degree was 2, right? So I changed them, and then here I printed it, and I printed it again. So here's AP, all the various values, and you'll see before I changed it, function was poly, and after I changed it, function is exponential, right? And poly degree went from 2 to 3. Right, everybody kind of get that?
Sir, I have a question.
Yeah.
So I know that we have to play with all these parameters, but the two
Let me
things.
ask you not to ask questions about what we haven't done yet. Only ask questions about what's on this page.
I think we have done it, so I should ask.
Okay, what's your question?
So you have 60,000 training data, right? That's kind of fixed, right? We don't change that.
You could. All you have to do is change that number, and it'll change.
Then we don't. How do we know? Like we have 60,000.
I'm going to make the data for you.
Okay.
Right.
Okay.
We haven't gotten there yet. We're not doing digits. We're doing functions.
Mm-hmm.
Right. We're just learning x squared.
I was thinking about the lab 2, I guess it was.
Yeah,
like identifying digits. Right. Yes.
And probably we could get more of those if we want, but we're not learning images. We're learning functions. And the reason it's called regression is that the output of the function is a real number, right? We're not learning categories. We're trying to learn the function x squared, right? So those are our functions. What I was fighting with this morning was I learned about you put a star here And what a star allows you to do is instead of, before I had to have a list of these changes, and the star allows you not to have it in a list, but to separate the changes by commas. And that then gave me some grief about how to know I passed them from one routine to another. But if you don't care about that, you don't have to study this routine. I was just testing various things to make sure it still worked. All right, this is the routine where we have to make a function. All right, so what does it do? It inputs an x. Now, here x isn't a real number, of course, right? What is x? X is a tuple of numbers. And how many numbers is it? Well, in dimensions tells you how many numbers it is. All right. And an AP function, right, is, I've got a polynomial and an exponential, right? But you can plug in here as many functions as you want, right? And my functions aren't very hard here, right? So what I'm saying is, if the AP function is polynomial, then start from 1 and go through all the x1, x2, x3, x4, go through all the x's and take the product of that x squared, right? Because remember, AP degree is 2, right? So this will give you x1, I guess really x0 squared times x1 squared times x2 squared, right? That's what my function is. And then for my exponential, I just did, instead, here's the degree, which is 2 raised to the power of x1, right? So those are functions. And if you test it, here I tested it, here I had to call this, remember, because it's a global variable. So we have to make sure we have the values set. We set them to default. And then I ran this routine and it came up with 36. Why is that? Well, it's 2 squared times 3 squared is 36. And 2 to the 2 times 2 to the 3 is 32. So that's the polynomial and the exponential, right? Does that make sense?
How was the numbers again? Sorry,
What?
didn't get it. When we the argument is 2 and 3, right? The list of 2 and 3.
Yeah. So
How was,
if we're doing polynomials, 2 squared times 3 squared, right,
okay,
is
according to code.
6 squared, which is 36,
Mhm.
right? And then I changed, right? I reset my APs so that function was exponential. And then it was 2 to the 2 times 2 to the 3, which is 32, right? Does that make sense? Excellent. All right, so somebody was really cranky at me this morning saying they don't want to have to know Python, but surely you can write some little routines like that, right? You just have to write. Right? You have to write some functions. I think you can do that. All right, so now this is a plot routine. And what it does is it's given a value R and it's given a tuple of values X, right? One value of X. And what it does is it ranges R. It chooses the R indicates which variable we want to change, right? So we're going to keep all the variables in our tuple fixed, and we're going to vary one here. So I tell you, we're plotting, right? In fact, let me show you what we're plotting, right? Here we're plotting. R1 is going to range from 0 to 100, and the other variable is going to be fixed to 1. Oh, my R, that didn't quite, there's a bug. I used to have it so that it checked, it put a number there, but right, and here's, right, there's the exponential plotted. Here's the quadratic plotted, right? And so what it's doing is it's fixing x r, right, x sub r to be a fixed number. Oh, no, it's varying xr from 0 to 100, and all the other values are constant, right? So how do we set all the other values? We set them by this x. We'll set all the other values, right? Of course, it's setting xr as well, but that gets ignored, right? Does that make sense? And then it's plotting it. You could go through the code and seeing it's pretty straightforward. It loops through, makes all the points, and then displays the plot, right? Does that make sense? Everybody good with that? And by everybody, I mean Adnan, because he's the only one talking to me. We've lost our usual. Hey, you're back. We were missing you. I can't hear you, but are you following this so far?
Yes, sorry, my kids keep coming asking, so I don't want to disturb.
Oh, I don't mind seeing your kids.
They
All's
left.
well.
They went.
All right. So everybody get this function, and you might see I also have here. You can pass in a network. So if you've already learned, then it will plot that one. It will plot the learn guy as well. You pass in the network that you've learned, and this should plot on the same graph. It should plot both the function that you've created and the function that you've learned, right? And hopefully they're pretty close. Though my prediction is that it'll look stepwise like I did on the slides. Right? Does that make sense? All right. Now this routine, it produces all our data, right? It produces our training X, our training Y, our test X, our test Y. And oh, one thing I haven't told you yet, and I thought I had a slide about it, but maybe it's somewhere in there, is there's this thing called, you come right back up to the top. This is where I'm importing and everything. And one thing I'm importing is called MUPPY, and I don't know what it stands for, but it has, I think it's algebraic things, right? It has square root of X in there. But it also has something, I guess here we're importing it at, right, an NP. Anyway, what's an NP? It's, what we talked about lists, and you can have lists of lists, right? Brackets with brackets inside. So that allows you to have each list of lists can be all different sizes. And some of the items can be strings, and some of them can be anything, right? So if you restrict yourself so that if it's a list of lists, each list is the exact same size, right? It's basically a matrix. It's a matrix of real numbers, right? Then we're restricting ourselves down, and all the algorithms will be faster, right? Because so NP is basically, it's like a matrix. It's either an array or it's a matrix of real numbers. And the advantage of it over a list is that coding's faster. All right. So okay, here. What are we going to do? We're going to produce all these things. How many training data, how many test data, the number of dimensions, right? I'm just doing X1 and X2, but you can have as many variables as you want. You know what I mean? And then I'm having each variable, right? Each xi between 0 and max. I guess it's actually 0 and max minus 1. Right? If we were going to be more accurate about that. Right? Does that make sense? And then what do? We just build the table. So here I'm just, right? So what is, here, let's come down and look at it. Here's my, this is my X value, right? So actually up here, I call it build X and Y with 4 elements instead of 60,000, right? Why I didn't want 60,000? Because I didn't want it printing them out, right? So if I'm having 4 of them, see X, here's one value of X, right? It has 2 values, X1, X0, and X1. And here's the second value of X. Here's the third, here's the fourth, right? So my data has 4 X values, and each X value has an X0 and an X1, right? Does that make sense? So it's basically a matrix. And the Y, right? Y only has 1 output. And so here's the output, right? Does that make sense? And oh, and here's this, when I build it with the larger, this is the shape. The training data has 60,000 entries. Each one is a dimension 2, right? While the training Ys are 60,000 by nothing, right? Does that make sense? And I keep moving to some funny place. All right, we're back here. All right, so basically to no plot, we don't want plot. We want here. Basically what it does to make the matrix, right? You loop through all values of I, all values of, right? All values of I in the range of how many items you have, all values of J in the number of dimensions, and it randomly makes a number between 0 and max, right? And it's a real number, not an integer, right? So actually, if you care how I'm doing it, this routine returns a random number between 0 and 1, right? And so then I multiply by that the maximum, and that gives me a random number between 0 and the maximum, right? Everybody good with that? Right? Am I going too fast? Should I slow down?
Sure, so what is that AP? Oh, a temp parameter. Okay.
Oh, this is all through everywhere. It's the
dictionary, right?
It's the dictionary. I forget what
Sure.
A is. You're trying something. It's
Attempt parameter.
attempt parameter, right?
Yes.
The attempt parameter, we're attempting to do this where this is our max value, right? And we could try different max values. I made everything an attempt parameter, right? And
sir, one question, sorry. What is a subplot? It was a function on top, I think. Or not a function, sorry. It was
up here?
Yeah, it was on top.
All right. So here, I only have one plot, right? But if we've already learned our thing, then there would be a plot of the learn function as well. So I'll have 2 functions, 2 graphs on top of each other, right? And so the one plot is plotting here, right? My X, this is my X value where I'm changing XR, right? The value of XR is changing. And here is F calculated on those values, right? And but down here, the subplot, right, that you asked about is if we've done a network already, then we will have a new plot, right? 2 plots on top of each other. That's why it's called a subplot. And we will also plot here, YL is the learn function, right? It'll plot the different values of XR with what your neural net. This is the answer returned by the neural net. And this line here does it for us, We have, this is all our X values. This is a whole tuple of lots of X's. And in one big swoop, the network runs them all and gives us gives us the output for all of them. Right? Does that make sense?
Yep, that makes sense. Thank you.
And you guys can study this code, and then next class we can chat about it some more, right? All right, so here.
Sorry, so what exactly are we, I mean, I don't want to stop you. Okay, go on. At the end, I'll ask.
At the end, we'll talk about what you're supposed to do.
Okay, sure, thanks.
I don't, and it's not really clear, right? So let's say, all right, so now what are we doing here? We're generating the X matrix and the Y vector by looping over here. And I'm pretty sure it's better when you're doing NP things, when you set up the whole matrix, right? This gives you a matrix of zeros. So it knows the dimensions and it has it set. And then I go through and I change the entries. Pretty straightforward, right? And then we build the training data and the test data, right? Does that make sense? All right, here's adding noise. Basically what it does is it goes through all the X values and all the Y values, and it adds noise. So it takes some random number and it adds that noise on. And my thinking is to do that for the training data, but not doing it for the test data. And my thinking is, right, you first have the real value of X, and then you get the real value of Y based on the real values of X's. And then after you add noise to the X's and to the Y's. And then you see how well the machine learn, does that hurt your machine learning, right? And I haven't tried, I mean, I did a test run here. I had, here's some X and here's some Y, and I added plus or minus a half to it. And it seems to work, right? Does that make sense? So here's where we're doing the learning, all right? So what's the input to learning is the number of training data and the training X and the training Y. I've made more parameters than this that could be added, right? There's the number of layers, the number of hidden nodes at each layer, epochs, batch, but I've changed some other things to be as well, right? And then this is just what we did in lab 2, right? We say our network is going to be sequential, right? And how many inputs does it have? Well, it's the number of dimensions in our X, right? We're feeding an X, and X has X1 through Xn, right? So that's how many inputs there are. And what activation are we using? Well, remember I should have changed it here too. I made this change just seconds before coming up here. Here, the activation we're using was the rectilinear, right? And I'm just changing it here. So here, let's grab this and replace this. All right. So right now it's set to rectilinear anyway, but it's just you could change that automatically, right? And this is how many nodes are at each layer. And then we loop over how many layers do we want the neural net to have, right? And then here's our top, right? Adding more layers. And then the top layer, how many outputs does the top layer have? It has 1, which is going to be our Y value. Now, it's not working very well. And one of my guesses is what activation do I have at the top, right? I want the top to be just a real number. So my thinking is you don't want any activation there at all. You just want it to be the sum at the top. And so so I didn't add activation here at all. I did a little Google search of how to do regression, and nobody taught, well, you know, I didn't read it. I just skimmed it quickly. And I didn't see anybody use an activation level. So I just didn't put an activation level in here. And maybe that's why my program's not working. All right. And then, right, all dense layers. And then you compile it, right? And I've made the error be mean squared, some mean squared, right? And right before we were using the outputs were these things that look like probabilities. So the error function had to deal with these probabilities. But now our output is a real number and we're comparing it to a real number, so we can take the difference and square it and sum up, right? Does that make sense? So that should all work, hopefully, right? That's what our loss function is. And we compiled, oh, here I just say, with the digits, we use this program and that optimizer, which, and you can't use accuracy, which says the percentage right, because none of the answers will be perfect, right? They're both real numbers. Anyway, we can discuss these various options, and then it trains, right? And then it learns, right? It fits the model to our training data, right? Everybody buy that? So this is the routine for learning. Then I have another routine called all. And what does all do? It kind of does everything, right? So you can pass it your new AP values, right? This just you're passing it changes to the AP value. Remember, everything will be the default values except the things that you listed, right? So here, if you call all on function should be exponential and degree should be 3, then all the AP values will be the same as the defaults, except it's going to change function to exponential and degree to 3, right? So here we're passing, and it's a list, right? Here's a list. That's why you need the star to make it a list. And what took me an hour to figure out is to put that star in when we pass it to the set, so that it doesn't get confused. Anyway, and then, all right, so we set our attempt parameters, and then we build our training data, right? You can have this, right? And then you add noise if you want to, right? Right now, noise is set to 0, so it doesn't do anything. And then it learns, right? And when it learns, it returns the learned network, right? And then what do we do with this network? We evaluate how it does on the test data, and this will give us some number, and which is it should be our sum squared error. And then, all right, and then, so that's the end of that routine, right? And it returns, what does it return? It returns the network in case you need it. It returns how well it does on the test data, right? And so here I'm testing it on, just their basic parameters. And if you see what our loss is, it's horrendous, right? I mean, there's no way that that's a good number. So I'm doing something wrong. All right. We got one more routine. Is everybody still with me? How you doing,
Yes.
Shanaz? Am I killing you?
Hey, kind of. It's a little advanced for me.
Do you have any questions?
Not yet, no. I want you to finish and then
All
we'll
right.
see.
All right. All right. So we only have one more routine. One or two. Let's see. One, maybe we have two. Anyway, let's do this routine. What it does is it makes a new graph for you. All right. And let's see how you call it first. It's called plot AP because those are our attempt parameters, and you're trying to plot. And what the plot will be is I'm going to, and what we're doing here is we're going to keep all the parameters fixed. Right, all those default values will be fixed, and all we're going to change is the degree, right? And which degrees do I want to change? I want to try degree 2, 3, 5, and 10, right? You can put anything you want there. And so I ran it, and this is the error on the various values. And I don't think it means anything because no, this is I don't know, this is a different graph. Ignore this graph for a minute. I was just testing some things. So anyway, you call it. And so here you can see what it's doing is it's saying I'm trying with degree 2, and here's the list of all my parameters, and you'll note the degree is 2. And then it tries degree 3, and there's all the parameters where everything is default except degree is 3. And then it tries 5, and then it tries 10, right? And so here's a list of everything it tried, and I just the answers I was getting for this is how well it's supposed this is supposed to be the loss when you had degree 2, and this was supposed to be the loss when you had degree 1. But since our losses are just big random numbers, it just didn't mean anything. So in order to test my program, I just stuck in constants. It's stuck in something easy. All right. So that's what this function does, right? See what you pass in it is AP parameter is going to be function. It's the, I guess here we're saying AP parameter in this case was degree, because we're going to change the degree, right? And then what is AP range? It's the range of values that we want to try our degree, right? We're going to try the degree with 2, 3, 5, and 10, right? And of course, we could have had this be activation level. And then what we're trying is we're trying the the rectifier, and we're trying sigmoid, and we're trying, right? You could list anything you want here that you want to try, right? And then what's the last parameter is AP values, right? It lists other values that you might want to change, right? So here, when I call it a second time, what this is saying is I'm doing exactly what I did before. I'm varying degree. Degree will be 2, 3, 5, right? Remember, the degree is our polynomial is, here our polynomial is x squared. Here's x cubed, x to the 5th, x to the 10th, right? And, but we're doing it this time where it's not a polynomial, but it's an exponential. And the maximum value is not 100, but it's only 5, right? And the one reason I set it to be 5 is because I was worried that when we do exponentials, our numbers would be would be too big to fit into an integer, right? So anyway, how does the code work, right? It just loops through everybody, all of these various options, and it builds most of the work is building the AP. And then once you have the AP, here I commented it out, but what you'll do is you'll run all, which right runs all of those things, right? And then you run, then it gives you the test value and you plot the test value. Does that make sense? So let's chat, you and me now. And I don't think, maybe you didn't catch all the nuances of the code, right? But anytime you have a problem with it, you can talk to me about it. But let me tell you what I'm hoping you to do. All right. I'm hoping that you will go to, first thing I'm hoping that somebody will do, maybe it'll be Chester, is to fix what I'm doing here so it actually learns well, right? So I don't know why it's not learning. We got to get Chester on it. The second thing, so now, then once that's done, what you're going to do is you're going to write various functions that you find interesting, right? Fill in some interesting functions. And if you want, I've given you lots and lots of parameters here, right? So you decide which parameters you want to vary, right? You might fix all the others to something and vary something else, right? You might want to know how well does noise affect things, right? You might want to know how well does the number of hidden nodes affect things. Like, for example, one thing I would love to know is that if you, this is my theory. Remember, when we did those blocks approximation, I had a theory that the number of nodes at the first layer allows, if it's 512, it allows you for the function to have 512 level steps, right? Blocks. And that's my belief. And so one thing I would love somebody to do is to change this value for, to make 10 nodes at that level and see, do you in fact have 10 blocks, right? You know what I'm saying? So it's just what we're doing here, the homework, it's a little vague maybe, but it's play with this stuff and report what you find. So, so you make new functions and then you decide which of these parameters you want to play with. And of course, my code could have bugs in it, but if you find bugs in my code, then we'll fix them. But if there are no bugs in my code, then what do you, Shanaz, actually have to do? Do you have to write all of this code? No, because that would be hard, right?
Yeah.
Writing all this code would be hard, right? It might be good for your soul to read over it a bit, but you don't have to modify it. So instead, look at this line right here, right? Let me re-explain what this line is right here, because the only two things that you have to change in order to get a passing mark is add some new functions and write some lines like this and some other lines. All right, let's first do these lines. There's, right, remember there are two types of graphs. One that graphs your function versus the learn function, right? So make a number of those, right? Make a number of them. And then the other plot is we're changing some AP parameter, and you plot how well is what's the loss function for all of each of those tries, right? And how do you do the latter? Do you understand what we're doing, Shanaz?
Yes, I guess we don't change anything. We just change that line and add a
All
few
right, so what
lines.
does, let's review what this line does, right? It's going to make a graph, right? It's going to plot something. And what does it plot? Well, there are a million parameters up there. And if we don't mention it here, it will be automatically be the default value, right? We're going to fix our function to be exponential. We're going to fix the range of a variable. Instead of being between 1 and 100, it's going to be between 1 and 5, right? And then what we're going to vary is we're going to try degree being 2, 3, 5, and 10, right? And what should that produce for us? It should produce a graph that looks kind of like this, right? It has, see here, at 2, at 3,
5 and 10. Yeah.
5, and at 10, it calculated some number, right?
Yeah.
And the number I calculated here is just garbage. I just stuck in something for pretty. But what it should return is what's the loss function when I learned with degree 2? What's the loss function when I learn with degree 5 and 10, right? Does that make sense?
Mhm.
Just look at this graph and say, look it doesn't learn as well on degree 10 polynomials as it does on degree 2 polynomials. Oh, that's interesting, right? And then you're done that and you do another one. Does that make sense?
Mhm. Yeah, now I'm kind of getting a drift of it. Yeah.
It doesn't feel, I'm hoping it won't be if we can get it to work, right? My bet is either we'll all crash and burn and for some reason it doesn't work, but I think it will work. We just have to fix something. And then it will just be pretty straightforward, right? Do you understand this line and what it's supposed to be producing?
Yeah, now I do.
Right? And you see how in my output here, these are all the trials, right? Here I'm trying degree equals 2, and everything is fixed except degrees changed to 2. And then I'm trying degree 3, and all my parameters are fixed, right? Except this is 2, 3, 10, right? Does that make sense?
Yeah.
So we would run the whole machine learning thing on this guy, and this guy, and in this guy, and on this guy, right?
Right.
Does that make sense? And let me give you a little of a warning. Don't make this list too big, because it takes about a minute for each one of these to run takes a minute, right? So you could set up a bunch of them and then go and have lunch, but don't expect it to work too hard for you, right? That's why I only did 4 here, because I only wanted it to take me 4 minutes to run, right? And then you'll see the second time we called it, again, we're doing degree 2, 3, 5, 7, but you'll see in this case, the function has all changed to exponential, right?
Yeah.
So that's what this is doing. Does that make sense?
So it's just these two functions, the polynomial and exponential.
Well, at the moment, I only made 2 of them.
I
Right?
see. I see.
But your job, I'm going to give you 3 jobs for this next test. Job 1, come up here. Come up here and put in some more functions, right?
Mm.
What functions should you put in? I don't know. Be creative. Think of something, right? Now, my functions are, I tell you what makes my function boring, because it's really basically just a function of one variable, right? So you want something that has some funny crosses, right? What makes it hard is that you're gonna have values x1, x2, x3, x4, and you want it to be some weird function of those, right? And if people don't know how to come up with functions, right, we can think about different things to try. All right, we can have discussions about different functions. Does that make sense?
Yeah.
So you try different functions, and then that's your first task. Your second task is to plot them, right? So here, this code, all you have to do here, right, is you call this sets function to be, you give your function a new name, right? Right up here, I'm saying if function is polynomial, if function is exponential, but you'll have another line that says if function is Shanaz, then you have some function here, right?
Yeah.
And so then down here, you set AP so that function is Shanaz. And
Mhm.
then you call it. And why does it have two numbers here? I'm pretty sure back then, oh no, down here. All right, so here, then you graph it, right? And graph it. What are the graph? I see. Right. R is which variable are we going to change, and X sets the values of all the other variables, right? So down here, I'm setting X0 to be 0 and X1 to be 1. So X1 is going to stay at 1. But X0 here, because we're changing the 0 guy, X0 is going to have 100 values between 0 and 100, between 0 and the max value in range, right? And so here we plotted it, right? Here we tried it. Here we got 100 values between 0 and 100, and you can see what it's outputting is x squared, right? So this will automatically plot whatever function you gave me, but hopefully you're also here. I'm setting the default. Remember, if it says equals as a parameter, then you don't have to call it, and then you don't have to put it in, right? But if you put here comma your network, right, then hopefully it will plot here what your network's answers are, right? Does that make sense?
When you say a function, you just mean any of the functions that we know, right?
Yeah.
Like you showed us polynomial and exponential, then there's linear, and there's a floor function, there's the step function, there's so many functions. So any of those, is that what you're saying?
Yeah.
Oh, okay.
Right?
That's
Some
fine.
function.
That's okay then, yeah.
Go back to high school.
Right.
If you don't know what a function is, phone up to your high school teacher.
There's so many rational, irrational, there's crazy. There's lots of
crazy functions. But what makes it harder than high school is in high school, your functions generally only had one input.
right.
And one output. And
Yeah.
I want functions that have n inputs, right? And somehow use them all in some weird way.
Mhm.
Right?
Yeah.
I don't know. But of course, when I plot it, that's why I plot it. I'm fixing all the variables except for one, and I'm just plotting it with respect to one of the variables. So it'll boil down to right? In this case, it'll boil down to just the variable, it'll just be a function of one variable, right? For this part, it might as well be a function of one variable, right?
Mhm.
But it might not learn as well. I guess that's what you could test right? You could test, well, if I fix all the other variables, it boils down to being x squared with respect to x0. You know what I mean by that?
Mhm.
It's a strange function of x0 through xn minus 1. But if I fix all the other variables and I just vary x0, it boils down to being x squared, right? So your plot here will always be x squared. But what does the neural net return, right? You've made it confused, right? You've given it all these crazy variables, and it does something different on all the crazy variables, and it has to muddle out what it is. So my bet is the more variables you have, and the crazier it is on those other variables, the worse the neural net will do, right? Does that make sense? And in fact, you could have a function that for any setting of the other variables, your plot with respect to x0 is always just x0 squared. But then as you vary the other, right, if you vary the other variables, well, you'll always get x squared. But when you vary the other variables on your neural net, you're going to get different graphs, right? Because your neural net doesn't know that it's always x squared, right? And so that might be fun, is to call this, right? Try plotting just this line right here, right? See, I set x1 to be 1, and I plotted x0, right? But what happens if I set x1 to be 100? Will I get a different, right? My function might be the same, but the neural net might give something different, right? And you know, the funny thing about this, I think the assignment isn't so hard. The one funny thing about it is that I don't know the answer, and I've never done it myself.
Sir, sorry, I have a question about the learner function.
Yeah.
Remember you said there was a graph and had cracks and it was learning new things, so it was changing, right? The slope was changing. If you could go to that graph, it was down.
Oh, this one down here?
Yeah, the one that was changing its slope. Yeah, this one.
This is wrong. So
It's
what's your question about it?
no, it's okay. You said that we have to, every time it changes, we have to learn, right? Something. Then, because that's what we're supposed to do by changing our,
Yeah.
parameters.
For each point here, you ask Google to learn a neural net for you.
What does that mean? Like, how do we ask Google to do a neural network for us?
Well, we come up here to learn. It builds a network, right? It has layers to it. It asks here. Here's the key line. You give it, you give Google training data, and it builds a network for you. Right?
Okay.
Right. This line here.
Oh, okay. By network.
The whole point of machine learning. Right. So what we're doing is, let's review the big picture. Is you specify some function, and then I build for you random x values, and for each of those random x values, I evaluate your x values on your function, right? So this is a collection of random x values, and this is the supervisor's answer for each of those x values. And the supervisor's answer is provided by your function, right? And then we ask the neural net, we ask Google to find a neural net that computes the same thing, right? So what is the neural net going to do? Is going to take some x value, x, and when I say x value, I mean x1 through xn. It takes some x1 through xn, and it produces a y value, right? I've lost where I'm pointing. Right here, take some x value, it produces a y value, right? And then what's the loss function? Right, then it comes down to, so that's where the learning is doing, right? It learns some network. And then and then what do we do with that network? Right? Google gave us this network. There are two things we can do with the network. The first plot is we plot your favorite function that you created, and on top of it, we plot what Google is giving us, right? And I'll tell you what I think it should look like. Your function will be this purple line, right?
Mm-hmm.
And my bet is that if on your first layer of your neural net, right? Right now there are 512 values, right? And so there'll be 512 different steps. So it'll look pretty good. But if you lowered the number of nodes at the first layer to being, here we had 4, right? We change it to 4, then the function will look something like this, right?
Mm-hmm.
And I think that would be cool to play with.
Mm-hmm.
Right?
See how we can get it more closer. That's basically our goal.
Yeah, we tweak the various parameters and we see how this picture changes.
Okay.
Right? So that's the one thing you're going to do with the network. And the second thing you do with the network is you come all the way down here. And so we tried it, we learned, and we built a network with this set of parameters. And we plot here, how well did it do on our training data? And then we do it a second time. Now, how well does it do on our training data? And
we just kind of analyze it by ourselves, right? Manually. Like
no.
How well
How do you get this plot?
No, how, like the performance, how good it did.
Oh, when you get the graph, then you can eyeball it.
Yeah, that's okay.
Right?
Okay.
It should produce this graph automatically. And then what do you have to do for your assignment? You say, hey, look at, I produced this graph, and then give me a few sentences why you think it's cool.
Okay.
Is it what you expected? You could say, hey, doesn't surprise me that when I have higher degree polynomials, it's harder to learn. Doesn't surprise me. Or you could say, hey, I expected it would do better with this, but it didn't, it did worse. Right? I don't know. So I would say produce a half dozen of these, a dozen of these, and for each one, give a little sentence about whether you thought it was what you learned and whether you thought it was cool.
Okay.
And whether it did something different than you expected. Right? Does that make sense?
Yes, it does. So I guess, how do we, I understand that we can graph our thing, right? Our own, like our function that we did, exponential, whatever function we choose. Right. But how, like the network would be as a neural network, right? How would we graph that? Would it be done like?
So, sorry for the interruption. You saw that message there? It means my computer's not plugged in. I'll be right back. I plugged in my laptop. All right, so if we come back up here to this plotting, right here, remember we set we set the the parameters to be function exponential, and then we graphed it, right? And it gave us those graphs down there, right? But another input is network. And I didn't give a network, so it's defaulting to no network. But if you gave a network, then what does the code do? It says, hey, if we actually have a network, then what do we do with it? Well, what we do with it is this capital X is the list of all our values that we used in our plot from 1 to 100, right? And it gives them all to the network. And the network gives us its answers. And then we add a subplot, right? We add another plot on top. And what is our subplot? It's plotting. These are all the values of the XR variable, right? Because we're changing one variable. And this is all the learned values. Oops, did I just change that? There. Right, does that make sense? And that plots it for you.
That's the plot part. Okay. I'll
Right?
for that. Thank you.
You don't have to do it. All you have to do is when you call it. Oops, I don't know where we are now. Oh, that's fun. How did that get there? It must be a video from something. Anyway, you saw yourself. All right, does that make sense?
Oh, so I see if you go to the parameter of this function, please, upward, network is equal to 0, right? That's the default
That's the default.
network.
Right.
Then it means that it accepts integers, right? Like its type is integer.
No, network is going to be some big object, some neural net.
Okay, so we can
Right?
do, okay.
And when I set it to 0, when I defaulted to 0, then if we were to run network with it, it would crash. It would say, no way, dude. And that's why I'm saying if network equals 0, right? This says, exclamation equal, right? This says if my network is not 0, then run the network. And if it is 0, then don't plot the network because we have no network yet. Right? Does that make sense?
I was just wondering that the type matches because it's
Yeah.
certainly an object.
One
Yes.
thing, one joy about Python, as far as I know, is you can stick anything in any variable, right? So right now I'm sticking a 0 in it, so it's checking that it's 0. But if you passed it the network that you learned, then it would hopefully it would plot it.
True, because you don't define the yeah, that makes it.
So we're gonna I'm gonna phone up Chester again tonight, and maybe if need be, I'll phone up my other friends. I have other friends who do neural networks, and we'll try to figure out why my neural network isn't working, right? And then I will change this so that it works. In the meantime, if you want to play with it, what you could do tonight is you could start writing different functions here and see and plot them and see whether they get plotted right. Right? And then when we get the neural networks running, then you'll be able to run them. Right? Does that make sense? Somebody asked, do we have, right? So yeah, that must be an old fork. Yeah, it's an old question. Yeah?
Oh, no, it's fine. I was just gonna ask is the ML page still on the home page? Because I think it's not there anymore. the link to the drive, I think.
I think I just went there. It's right there. Did you refresh the screen?
It's in the syllabus. If you go in the
Oh,
syllabus,
yeah. So
yeah.
if you go to
Oh, it's in the syllabus.
this version, it's not there. I never go there. That's the beginning of term. But if you reload syllabus, then it's there.
Yeah, I got it. Thank you. Sorry.
Yeah. Maybe it was, chances are you just had an old browser that patched it. Everybody good? How do you feel about this? Does it feel too scary?
It
I think
is-
it would be
it-
pretty
it
much
is-
similar to tests that we had that we would struggle at the beginning, but probably be good by then. Probably.
No. My bet it'll be the easiest test you've done so far. Right?
Probably the first one would be a little bit difficult because we have to, I guess, make ourselves familiar. After that, it would be probably.
Yeah.
easier.
Yeah. And I think you just have to call it and, you know, and we can talk about it. You can say, hey, this isn't working, and right. I certainly can tell you anything about my code, right? And then you right, and actually let's open up what cheating looks like. I would say if you want to Google the internet and ask it to give you some interesting functions from in inputs in real numbers to one real number, and it will give you some cool function and give you the code for it. That to me isn't cheating, right? Your goal is to find some cool functions and find them however you want, right? Go talk to, maybe you're taking some course from some professor and you say, hey, professor, give me some cool functions. I don't know. The goal here is to try and to learn, right? So there's no, oh, and I would say all of you can talk to all of you, right? There's no restriction to just talking to your partner, right? The only restriction is you have to hand in something different than the other guy does, right? Does that make sense?
Sure, and we don't worry about lab 3 and other labs. Only regression was the name of this file.
Yeah, I haven't really studied 3 and 4 yet myself. My hope was, my intention with this assignment was to give you as minimal Python learning as possible and to maximize your understanding of the power of machine learning, right? And I think that this does it because you don't have to change very much and you can try lots and lots of different things, right?
Oh, my daughter Sonia wants to say hi to you. Here you go.
Hey there. Thanks
Hello.
for sharing your mother with us.
You're welcome.
Merci.
She's our most active student. If she was,
Most oldest student.
well, that's closest to my age. That's why she and I bond so much.
Yeah.
She chats with me and she makes sure that we're all doing the right thing.
Okay, bye.
She told me that her daughter convinced her to take these crazy courses. Was that
Yeah,
you?
that's her. She's in 3rd year Waterloo, so she convinced me.
Excellent. 3rd year Waterloo. What are you taking?
I'm studying financial economics and business.
Cool.
Yeah.
Well, I studied at Waterloo and my son studied economics. So between me and my son, we got you.
Mhm.
He went to Guelph though,
Oh, wow. Nice.
but Waterloo's hard.
Yeah, it's hard, but I think any university is at the end of the day, if you don't understand, you know, the material and stuff like that, you don't ask questions to your prof, then you're gonna fail.
Exactly. Look at my screen here. Do you know how many people actually talk to me? Maybe 4.
Oh,
And I don't know how many are left in this course. There's probably at least 50 left in this course, but the morning course has, I don't know how many it has. 100.
no.
Do you talk to your professor?
Yeah, I'm always in contact with my professor. If I have any questions or anything, I just email them, book an office session, and
Right.
you know, chit chat about the course or any questions I have.
And you're all Zoom.
We use Microsoft Teams.
Oh, I meant, I mean that it's online as opposed
Yeah,
to,
it's online or it's pre-recorded lectures as well.
right.
But next term, everything's in person. So.
Yeah, same with us. Same
Mhm.
with us. What about you, Shanaz? Are you gonna come and take algorithm?
All right, bye.
Bye.
They keep bothering. That's why I turn off the video. They keep coming and asking questions. So
They're not a bother.
no.
I confess I'm out of the loop. This is a thing of age. You know, I look at your daughter and I think she's in high school. I was surprised you said she's old enough to be at Waterloo, but that's just because a sign that I'm getting old.
Yeah, that's how these kids look. You know, they all are young and energetic and
Exactly.
getting things done. And yeah, this
Exactly. We don't get old. Everybody else gets younger.
that's true. Okay, Jeff, I have a question. So
All right.
when is this due?
Well, isn't everything due on Fridays? Isn't it due a week Friday?
So on the 25th?
I don't know what day that is. A week, whenever
week.
the due.
Right. So that's next Friday. Yes. That's not this. That's the 26th, actually. Morning of 26th.
Yeah.
Right. Okay. And you said you're going to ask Chester to make sure that this thing runs, right? What happened? It froze. Oh, it froze. Oh, what happened?
Sir, you're mute. Officer, you're mute, probably.
Sorry, I plugged my computer into the outlet, but I didn't plug it into the laptop. So it died anyway. All right. What, you had another thought?
No, you were saying something because you froze. We didn't understand anything for the last minute.
Oh, my laptop died.
Okay, so sorry.
So you were saying something, I think. You were asking me a question.
Yes, so Friday, that's fine, it's due. And oh yes, I asked, so is Chester's going to like make sure that it runs and then we go and do our thing, right?
Yeah. So you can start, why don't you start planning what you're going to do and start writing some functions that you want to try and see if you can plot them on my program. And oh, you know, another source. Here's another page that's really fun. Where's my mouse? I have 2 screens, so I lose my mouse. There it is. If you go to my home page, and then you go to fun, and then you scroll up. Let's see how we scroll up on this computer. Scroll up to this. Have you heard of this program?
Oh, sir, the screen's not being shared.
Oh, I'm not showing the screen anymore. All right, so. Share screen, share screen. All right, remember, you see it now? You guys know this program,
Yes.
right?
Yes.
I bet you if you go into something, it will give you functions. I don't know where. Examples. Examples, plotting and graphing. 3D plots. Oh, right, here we go. Look right there. The plots. There. There's a function. Right? What is it? Right? It's a pretty simple function. Right? It takes on two numbers, right? And outputs a third. So, right, we can add on some things here, right? We can add on plus x times y. Didn't change it very much, but right, you could just try things. Maybe you play here. Maybe, you know, I restricted myself to 2 inputs. Maybe you could try things with 2 inputs and plot them here and see what you wanted to learn. Does that make sense? All right, anything else we want to do today? So I know usually not very many people come on Thursdays, but if people want to talk to me, they can tell me they're going to be here on Thursday. And then
Professor?
we're not here on Friday, right? We're here on Monday.
Yeah, tomorrow I have like a tutorial at the,
I never get you on Thursdays. I
yeah,
know that.
Thursday morning. I won't be able to.
Right.
Have, Professor, I do have a question.
Yeah.
So for the machine learning parts, I saw we have one dense layer here.
Uh-huh.
I don't quite understand because when I learned machine learning by myself,
Uh-huh.
I usually see 2 dense layers or some learning layers here, but I don't understand why we are using one point
Okay.
dense layer here. So
You want me to tell you I am absolutely 100% that you know way more about this than me. So you can help us all know what to do. Where's the learn thing?
So as I understand, so we have to set a bunch of like dots, and the Keras will compute for us,
Right.
and for each dot, and
Right.
we should add bunch of layers, which numbers of dots, and
Right.
I think it might fit better, I think.
So if you remove this, if you remove that, then what you get is the neural net that where did I get it from? I copied it from lab 2 where we did the digit learning. I'll tell you what I changed. I changed I removed the fact that we wanted to put, before it had here 10 nodes being outputted, right? Because there was, is it a 1, is it a 2, is it a 3? And we only want one value. And I removed the activation being probabilistic to being no activation because I just want the last value to be a Y value, right? I also changed the loss function to be mean squared. Do you agree? Would you agree with those changes?
Well, I don't know. It's
Yeah, I don't know either.
yeah.
Do you understand why we only want, we're trying to approximate one output, right? And so
Yeah,
that's why we want one number on the outside,
Okay.
right? And right, I'm imagining that the last layer is going to do a sum. And here, in fact, let me show you the picture. I think if you don't have those other layers, then it's going to give us this neural net, right? It's going to have, well, it might have a number. If we only had one X value, but you could have a number of X values. They feed into 215 nodes at this layer. And there they do a rectilinear sort of activation here. And then they all feed into a single node. And that single node is just going to do a sum, right? Here at our top layer, we're just doing computing the linear sum of the weights. And we're not putting it through anything because we just want a real value, right?
All right, that's
Right?
Sense.
Does that make sense? Now, if you're asking, do I expect our machine to be able to do it? Well, I just did it, right? I did it, but manually I came up with the weights. Here are the weights to learn this function, right? So I would say if I can do it, Google can do it.
Oh,
Right?
I think if we is not setting activation like model for this, it may do it by default. I don't know.
Yeah, yeah. So could I give you that extra job? Why don't you, if you search regression, the word for when you have one real output is regression. And I did a quick search and I didn't see them using any activation. I did a little search for regression activation function and I didn't see one. They all just left it blank. So I left it blank.
Oh,
And I didn't read any articles, right? I'm not a reader. But,
okay.
but
So
we could
that's a
give
part I have to.
investor gold stars if you can figure out why this isn't working.
All right.
Are you following what I'm saying?
Yeah, so I basically have to review I studied and Googling all of those stuff.
Good, good. So if you're our man, you can work on fixing it.
I don't know.
Yeah, I'm not
This is
saying you have
maybe-
to. I'm saying you can try, right?
So when I study those stuff, they're basically giving us a model to this, and we're just like trying to understand all of the stuff. And so I totally forgot now.
Right, right, right. So my goal here is just to give people a little flavor for it, right? Do you think we're asking students too much, or do you think they can handle this?
For me, I think it's okay.
Yeah, yeah, but I'm not worried about you because you've done machine learning already, right? I'm worried about the masses. I think they're going to be okay. That's my opinion is they're going to be okay. And the good news is if everybody crashes and burns, then it doesn't matter, because what only matters is how well you do compared to other people.
So we're running from like based on TensorFlow or some other stuff.
You know, I heard the word TensorFlow and I don't even know what it means.
So I noticed that in our code there is import Keras.
Right?
It's from TensorFlow or some
it-
other.
I don't know. Is TensorFlow a company? What is TensorFlow?
I think it's a machine learning like a library made by Google, I think.
Right.
And
And you think this isn't it?
and Keras is a part of TensorFlow.
Oh, okay. Okay.
And so I'm not sure if other library has Keras also.
Right. I have absolutely no idea.
Oh, okay.
You know, everything I know, literally everything I know, I got from Labs 1 and Lab 2,
Oh,
right? A year ago, I read briefly Lab 3, but I don't think I got through it,
okay. I
right?
think we have much work to do.
Oh, yeah? You think it's harder than this?
And it's kind of interesting, I think,
Right.
but need a lot of time.
Oh, yeah.
Okay, I gotta go, Jeff.
I gotta go
Yeah.
too. So
Okay, you all take care.
you all take
Bye.
care. And Beidou, if you know, Beidou Lee, if you can, the more you can give us insights, your insights, the better.
I don't know. I'm just a newcomer for computer science.
Right. Fair enough.
And
Welcome.
thank you very much today. And
Hmm?
thank you very much for today's teaching. And
Did you follow it? Was it good?
yeah, I think it was good, and the graph is great.
Great. Excellent. And I really do hope that in the end, this will be better than another couple of weeks on Turing machines.
Yeah, I think Turing machine is more about the logic, and machine learning is much about fun.
Yeah, exactly. So let's have some fun.
And I hope this will doing great.
Yeah. Maybe this will start whole careers, right? How many people in our class are going to start a career in machine learning because we're getting them to do this?
Yeah,
It's certainly where the jobs are.
it's a great start, I think.
Yeah.
So it's a late, and I basically have to leave. And
Yeah, me too. Me too. So have a great until I see you next.
you too. Thank you,
Okay,
Professor.
bye, everybody.
Thank you, Professor. Goodbye.
Thanks.